theory of everything is a single, all-encompassing theoretical framework of physics that fully explains and links together all physical aspects of our universe. Now, our universe is made up of atoms and subatomic particles such as neutrons and protons, which are lastly made up of point particles called quarks. At least that's the conventional view. These particles are held together by only four forces: gravity, which is explained by general relativity theory, and other three are electromagnetism, strong nuclear force, and weak nuclear force, which are lastly described by quantum theory. These theories, general relativity, which is the theory of macrocosmic world, or in other words, the big world that includes galaxies and stars, and quantum theory, which is the theory of macrocosmic world, which describes regions of both very small and low mass, molecules and atoms. These theories are what all modern physics rests upon. The important thing about them is that they're both correct if they work separately, but when applied together, they completely oppose each other. However, the Australian issue as they're almost never used together, but their incompatibility is an issue in regions of extremely small scale, such as that exist within a black hole. You see, a black hole size is small in terms of length, but large in terms of mass, so we need both theories. The solution to this problem is theory of everything, which will unite gravity with other three interactions. So, in pursuit of this goal, scientists found a standard model that successfully explained the three non-gravitational forces: strong nuclear, weak nuclear, and electromagnetic force. But there's still a problem. Gravity still does not fit into the equation. That's where string theory comes along and does the job of unifying all four of these forces. String theory suggests that every particle in the universe at its most microscopic level consists of varying combination of vibrating strings. That means, according to string theory, quarks on the end of the story. Inside them, we'll find a string-like filament of energy, and just like a string on a guitar.
Musical analogy. Really? You can't think of anything else?
Sorry. String vibrates to create a musical note. The strings in string theory vibrates and produces particles themselves. So different particles are a result of different vibrational patterns of a string. We know we live in a universal space-time which is four-dimensional, but strings vibrate in more than 4 dimensions. That's how string theory allows for 11 dimensions. The other 6 or 7 dimensions are believed to be tightly curled up. We may never be able to see them because they're very, very small, or they might not even exist, and string theory just isn't true. But if you express it in 11 dimensions, Einstein's theory of relativity pops up.
Coincidence?
But scientists don't believe in coincidences. The math is there, but there's still a lot to do to complete this theory. Perhaps it'll be one of us who will do it and achieve the Holy Grail.